All right, so we're going to talk about the classification of matter for your essential skill. There are basically 8 definitions that you need to know in order to be successful with this essential skill. The first one is a pure substance. Pure substance and mixture are basically opposites of each other. A pure substance is a sample of matter that contains only one kind of matter. With that being said, I have 2 boxes here, so I'm going to show you 2 different pure substances. This is going to be a zoomed in picture of the individual particles in a pure substance. So if I had an element, it would have all of the same particle. Whether they're connected or not, it would just have the same particle. So if I just had some X's in groups of 2s, that would be one element. That's a pure substance. Compound, on the other hand, looks a little bit different, and it looks a little trickier because you actually have different symbols. So compound, this would be an example, let's say water. So 2 hydrogens would be the X's, the O would be the oxygen. Even though there are different symbols, this would be an example of a pure substance because the 2 different groups of symbols in this compound box are the same. So even though the symbols themselves are different, the grouping is the same, which makes it a pure substance. Mixture is the next definition on your classification of matter list. So a mixture, again, is the opposite of a pure substance. It's a sample that contains 2 or more kinds of matter. So if I had some triangles that were individual elements, and then I put those with some circle-square combinations, then that would be a mixture in this box. Okay. Next is an atom. An atom is the smallest particle of an element. An atom is just one single particle. So if I just had a bunch of triangles, then that would be 3 different atoms within this box. A molecule is the next definition. Molecule, again, I'm going to show you 2 different versions, but it's any atom that is connected together. So the key word here is any. It doesn't matter if they're the same, it doesn't matter if they're different. As long as there's some sort of link, it's going to be a molecule. So if I had some circles connected together, that would be a good representation of O2, or the oxygen that we breathe, because it's 2 oxygen atoms connected together. That's a molecule. There's a connection there. Another example of a molecule would be if I have an X, and then I connect it with a square and another X. So again, that could be water. I could have a star and a circle connected. That would be another molecule. As long as there's that connection, it's going to be a molecule. Elements can either be a single atom or a group of the same atoms combined together. So anything on the periodic table is a great example of an element because it's a periodic table of elements. So if I had single individual atoms, this could be like any of the noble gases where I just had particles that were by themselves. So that's 3 atoms of the same element. If I had those X's and they were connected, then this would also be an element, but it just looks a little bit different. As long as you have the same symbol in there, it's going to be an element. Okay. Compounds, the key word in a compound is that they have to be different elements. So it's 2 or more different elements connected together in a specific way. So sodium chloride is table salt. If I had an X as my sodium and an O as my chloride, then I would have table salt there with that XO combination. So it has to have a link between different elements. So again, you could literally put a whole bunch of different things together and you'd have another compound. Okay. 2 more quick definitions. Homogeneous, these are now no longer the zoomed in pictures. So this is big picture, what you can actually see. And the key thing to remember is that homo means same. So if I'm thinking of something that is homogeneous, it means that the sample looks the same all the way throughout. So it looks like there's just one thing there to our to our eyes. So Kool-Aid, milk, stainless steel, all examples of things that are homogeneous. Last definition real fast is heterogeneous. It's the opposite of homogeneous. Hetero means different, so the sample has to look different throughout. So it looks like there's more than one thing there. You can actually see the different parts of the sample. So if you look at the ocean, you have the animals, you have the shells, you have the water, you have the sand. You can see those different samples of matter. If you're looking at the granite over here, you can see the different minerals with the different colors within the rock. And then, of course, the soda pop, you can see the ice, you can see the soda, you can see the carbon dioxide. So there's a whole bunch of different parts to that sample. I hope this helped. Review your definitions for the classification of matter. Good luck, guys.